Hope you're doing great today. It's bright and sunny here, but a little bit cold, chilly, as you would expect this time of the year. I hope the weather is great at your place. For those of you who do not know me, I'm Dr. Nandi. I frequently go live on my YouTube channel discussing math problems. I've also uploaded a number of YouTube videos on different math topics. When you get a chance, please take a look at my channel. If you like these videos, give me thumbs up. If you like this video, share with your friends, and please subscribe to my channel by hitting the red subscribe button. So without further ado, let's talk about today. Today we are going to discuss how to solve a problem on sampling distribution of proportion. Okay, sample proportions. So here's the problem. A candidate for an election is favored by 48% of all voters. A polling organization will take a random sample of 500 voters and will use P hat. This is to be read as P hat with a thing at the top, P hat. The sample proportion to estimate P. This is the population proportion, this is the sample proportion. P without the hat is the population proportion. So they will use sample proportion to estimate population proportion. What is the probability that P hat, that is the sample proportion, will be greater than 0.5? So let's read the first line again. A candidate for election is favored by 48% of all voters. So P is the population proportion of all voters who support the candidate, who support this candidate. P as given, P is equal to 0.58. Notice this is the population proportion. I'm sorry, 0.48, 48%. Okay, comes from here, 48%. Now we are using a random sample of n. Its sample size is 500. Sample size is equal to 500. Okay, this is a problem on sampling distribution of sample proportion of P hat, which is the sample proportion. Okay, this is read as P hat, sample proportion. So what is the sampling distribution? It is like this. You have different P hat values on the horizontal axis, and you have probability on the vertical axis, and this is a bell-shaped distribution. Okay, so this is a bell-shaped distribution. This is the sampling distribution of P hat. Of P hat, that is sample proportion. P hat is sample proportion. Okay, we can use this sampling distribution to solve this problem, provided we first calculate, this is the sampling distribution, n times P. Remember, our n is 500 and our P is 0.48. So we will use our calculator and calculate 500 multiplied by 0.48. 500 multiplied by 0.48 is 240, and that has to be greater than 10. Okay, Also, we will calculate n times 1 minus p. That is 500. Then left parenthesis 1 minus 0.48. This is 0.48. 1 minus. And then right parenthesis and equal to. So 500 is a sample size. Left parenthesis 1 minus 0.48. Right parenthesis is 260. That is also greater than 10. Since both n times p and n times 1 minus p greater than 10, we can assume a bell-shaped distribution, a normal distribution for p hat, like what we have done. Now the center of this sampling distribution of p hat, the value where the relative frequency or probability is highest, this is the center, mu p hat. Now from central limit theorem for sample proportions, mu p hat equal to p. Now p is given to us as 0.48. So this is mu p hat, it is 0.48. Okay. Also sigma p hat, which is the standard deviation. So this is the mean. Standard deviation is given by sigma p hat is square root of p times 1 minus p over n. Okay, so how will we do this calculation in our calculator? We'll press the second button and then we will press the x square button to get the square root. Inside the square root, first we will type p value, which is 0.48, then put the left parenthesis 1 minus 0.48 inside the left parenthesis, then end it with the right parenthesis, and that has to be divided by n. N is 500, and then you enter. So sigma p hat will be equal to, like I said, it is second button. In my calculator, what am I doing? Second button and then x square, which is halfway down in the first column, gives me the square root. Inside the square root, 0.48, left parenthesis 1 minus 0.48, then right parenthesis, then divided by sample size of 500, n, okay, and hit enter. And it is 0.08, sorry, 0.0377. So mu p hat is 0.48. Sigma p hat, the standard deviation of this distribution, is 0.0377. Okay, so it's 0.0377 standard deviation. Now we have to find out what is the probability that p hat will be greater than 0.5. Now at the center, p hat value is 0.48 because it's equal to the population proportion. 0.5 is greater than 0.48, so 0.5 will be somewhere on the right of 0.48. Further, we want to find the area to the right of 0.48. So we want to find out what is the probability that p hat will be greater than 0.5. That means area to the right, area under the normal curve to the right of to the right of 0.5. So how do we find area on the normal curve? We will use the calculator. Okay, so we will press the second button, then we will press the verse button in the third row, then we will select the number 2, which is the normal CDF. They will ask for lower boundary. We are starting our calculation. As you know, we are starting from 0.5, anything to the right of 0.5. This is 0.5. So 0.5 is located over here. We want to be the right of 0.5. So lower is 0.5. As you know, this curve stretches to infinity on the right. So upper infinity in the calculator will be 1. Then second button. Then the comma button. Where is the comma button? On top of the 7 button. Gives you the small cap E, which stands for exponent 99. We type. So we type 1, then second button, then comma button, get the capital D, small cap E, then 99. 1 followed by 99 0. It is a very large number on the right. Okay, 1E99 is your upper. What is your mean? Mean is 0.48. What is your standard deviation? We already found out is 0.0377. And then we go down to paste and hit enter twice. Okay. So let me do that in front of the camera. So what am I doing? I will press the second button, then the verse button, which is in the third row from the top, and then select number 2. It asks for a lower. The lower is where we start our calculation from. We want to be the right of 0.5, so the lower is 0.5. Upper is a very large number, 1. Then second button, then comma button on top of 7. We get the small cap E and then type 99. 1 followed by 99 zeros. What is the mean? The mean is 0.48. What is the standard deviation? 0.0377. So second verse 2. Okay, then lower is 0.5, upper is a very large number on the right. 1E99 signifies infinity. Mean is 0.48. Standard deviation is 0.0377. And then we go down to paste. Whenever you are on paste, the cursor is on paste, hit enter twice. And the answer is probability of p hat greater than 0.5 is equal to 0.2978, or there is a 29.8% chance that the sample proportion will be greater than 0.5, which is quite a bit high probability. So let me recap what I did. So a candidate for an election is favored by 48% of all voters. So P, the population proportion of all voters who support the candidate, is given as 0.48. A polling organization will take a random sample of 500 voters. So N is sample size is 500, and will use P hat. This is P hat, the sample proportion, to estimate P. Okay, the first thing we should realize, this is a problem on sampling distribution of P hat. P hat is the sample proportion. So P hat on the horizontal axis, probability on the vertical axis. Is normally a bell-shaped curve, but we need to check that. So we calculate N times P. Remember, N is 500. Population proportion is 0.48. 500 multiplied by 0.48 is 240, greater than 10. And 500 multiplied by 1 minus 0.48 is also greater than 10. We need to check those, then when we can assume that the sampling distribution of P hat is bell-shaped or normal distribution. And then we will use the central limit theorem for sample proportion, which states that the center of the bell-shaped distribution, sampling distribution of P hat, is mu P hat is equal to the population proportion is 0.48, that is the mean, and sigma P hat, the standard deviation of the sampling distribution, is square root of P times 1 minus P divided by N. How do we get the square root? It is second button, and extra square button gives you the square root, and it is 0.48, left parenthesis 1 minus 0.48, P times 1 minus P, then divided by N, sample size of 500, and enter. Sigma P hat, the standard deviation of the sampling distribution, is 0.0377. So we got the mean, we got the standard deviation of the sampling distribution. Then they ask for what is the probability that P hat will be greater than 0.5. In the sampling distribution, P hat greater than 0.5 means the area under the sampling distribution normal curve to the right of 0.5. So we start our calculation from 0.5, that is my lower. My upper is a very large number on the right, which is 1E99. 1, then second button, comma, gives you the capital E, then 99. What does it mean? 1 exponent 99, 1 followed by 99 zeros, which tells the computer or calculator that it's a very large number on the right, infinity. And then we type in the mean as 0.48, standard deviation is 0.0377. Bring the cursor on PEST. One thing to remember on TI-84, when the cursor is on PEST, you hit enter twice, and you get the probability as 0.2978. This is the area under the normal curve to the right of 0.5. Or in other words, there is a 29.78% chance that the population proportion, that the sample proportion will be greater than 0.5. P hat, very high probability. Okay. So, what am I going to do? I'm going to stop here. If you have any question, comment, write me a note. Do not hesitate. And I'll respond to each and every question that you have. And I appreciate the fact that you took the time to watch this video. Really appreciate it. So if you like this video, please give me a thumbs up. That means a lot to me. It motivates me to produce more videos just for you. And if you like this video, share with your friends. If you like this video, please subscribe to my channel by hitting the red subscribe button. At the same time, please click on the notify bell button, which will notify you every time I upload a new video. Again, thanks for watching. Okay, and I would like to know where you are watching from, so you can leave a note that I'm watching from this city. I really appreciate that. And again, please do not forget to check me out tomorrow when I will be talking about another new problem. Thanks for watching. Take care. Have a nice day.